So our next speaker now is Aviv Dekel. Aviv is the Chief Operation Officer in Business Development at Co-Energy Ltd. She is responsible for the international commercial activity of Co-Energy, establishing the company's presence abroad, conducting market research and outreach. Aviv's presentation will be connecting the dots between waste, energy, and decarbonization. So Aviv, over to you.
Thank you, Wayne, for that kind introduction. Let's start with the bottom line. Okay, if we want to make sustainability work and the clean tech work, then the clean tech industry needs to be green, not only for the environment, but also for the bank accounts of the stakeholders. I'll speak a little bit about how we at Co-Energy think about the clean tech industry, and then I'll elaborate more about Co-Energy and how our technology answers the challenges that we identify in the clean tech industry. So when you look at the clean tech industry as a whole, you can identify three major trends that evolve kind of separately and in parallel lines. So the first is the growing need to upgrade waste management technologies. We are literally drowning in waste, with the startling figure of 2.3 million tons of waste per day. Those need to be treated better than what we did so far. Landfilling, incineration-based solutions, most of the gasification solutions, those don't work anymore, and we need to think of something new. So that's one challenge. In another area, second trend is in the energy sector. We see growing desire to rely on renewable energy resources and freeing ourselves from dependence on fossil fuels. And if there was ever a time in history that demonstrated how much energetic independence is a pressing need, then this is probably it. So energy transition is another pillar that grew. And the third trend, which grew in parallel, was the decarbonization goals, with the aim to reduce the greenhouse gas emissions. And today we're at a point that net zero doesn't cut it anymore, and we need to think in terms of net negative. So these three trends kind of grew side by side: the waste treatment challenges, the demand for clean resources for energy, and the decarbonization targets. And the clean tech industry nurtured these three pillars, both separately and in some variations combining them, but with only limited success. And you have to ask yourself, why is it? Why don't we see this growing industry and surge of investments from private companies, not from the government sector? And the answer is, in our opinion, is that most of the technologies that were presented to date either didn't work, or if they did work, they found it hard to present a solid business model that would support them. And this is where Co-Energy came into play. Co-Energy is an Israeli startup. It was established in 2014. And from 2014 to date, we grew bootstrapping without external investments, and we conducted ourselves from revenues from projects. The company is led by a very well-experienced team of engineers, all of whom with a long mileage of bringing technology companies from seeds to exit. I am the only non-engineer in the group, and probably average the age down a bit. And when we entered the clean tech industry, we knew that we must present not only outstanding technology, but also a rocking business model. Otherwise, it won't fly. So how do we do it? We look at waste, and we look at energy, and we look at decarbonization, and we connect these three dots together. We look at waste not as a nuisance, but as a renewable energy resource. We take waste, and through our IP protected technology, we have several patents pending in the US. We convert it to energy in the form of hydrogen, electricity, fuel, or biochar. All of that is executed in a net zero or a net negative environment, depends on the input material. So when the technology and the finance meet, then the result is current capability. To kind of relate to the previous presentation, we have current capability to produce hydrogen from plastic at a cost of $2 per kilogram today, not in 10 years, but today in 2022. So this holistic approach that marries the need of one pillar, which is the waste management, with the needs of other pillars, which is the decarbonization and the energy sector, all of them fit together in this very financially feasible model. So that enables us to offer our clients an outstanding return on investment rate and make sustainability financially attractive. And when sustainability is green in the bank account, then we don't need to rely on government subsidies or grants or external funding or even the goodwill of industry pledges. If the business model works, everybody wants a piece of it, and that's how the clean tech industry should develop. So we are already commercially active in Israel with that business model. And to name just a few examples of projects that we're involved with. So first is that we had a plastic recycling company in northern Israel, for which we built a plastic to electricity system. So I'm talking about business model alone. Okay, the technology works. So the client profits once when he gets gate fee for the plastic, profit twice when saving the landfilling fee for some of that plastic that he can't recycle, profit third time when he doesn't purchase electricity from the utility, and profits for the fourth time when selling that excess electricity back to the grid. So with that business model, converting plastic to electricity makes much more sense than just getting rid of it in illegal dumping or landfilling. Another example is the case of taking feedstock manure and converting it to biochar. In this case, the client profits when reducing the cost of handling the sludge and the manure and all that organic waste that is, as you know, is under rigorous regulation from environmental laws. And they profit twice when they use the biochar back in the soil instead of investing money in purchasing compost. And they profit for the third time because biochar is actually one of the best carbon capturers known, so they can sell the offsets in the carbon market. And as I mentioned earlier, the cherry on the icing, the capability to take plastic waste and convert it to green hydrogen at a cost of $2 per kilogram. And the way we get to the cost of such low costs in hydrogen production and actually have very minimal period of time for the return on investment is that the raw material doesn't cost us anything. And not only does it not cost anything, our clients actually get paid to get the raw material. So we have the technology backed by a business model that works. The list of projects goes on. The variety of solutions is very extensive. Co-Energy, we're now interested in entering the North American market, and we're looking for right strategic partners to go hand in hand with. So if that interests you, we would love to hear from you. I'll put my personal Calendly link in the session's chat right after we finish the presentation. So feel free to schedule a meeting or drop a line by email, and I'll be happy to take any questions. Thank you.
Thank you very much, Aviv. That's great. I love the way that Co-Energy kind of rides in two different fields. And if I can ask you a question, in fact, Gil in the audience has asked if you have a visual version or summary. So maybe if you have a diagram or schematic that you could pull up to show what the system looks like, that would be great. In the meantime, I'd like to ask you something. Obviously, as a startup, every startup is always told to focus, focus, focus. And here comes Co-Energy with a great, very robust business model. but you're involved both in dealing with waste and dealing with energy. How do you address that? You know, what is your target market? Do you consider yourselves an energy company or a waste treatment company?
Great, thank you for that question. So we think the most pressing problem is actually the waste management issue. And the amount of waste is so huge that actually the only market who could absorb such quantities of waste without having to invest a lot of new infrastructure or having to really change their current management is the energy sector. All right, so if we look at the energy sector, there's a growing trend to rely on distributed energy resources and renewable energy resources. So we consider our systems mini power plants that we can manufacture either hydrogen or electricity or fuel. The fuel is actually much cleaner than fossil fuel because it doesn't contain any lead. So we address our clients are in the waste management industry. That's definitely our target market, from municipalities to landfills to waste management companies. But we marry the two markets together and create a solution from one market in the other market without burdening it.
Okay, thank you very much. That definitely makes sense. You know, diving into the technology, how scalable is it? How would that operate? Or maybe that again comes back to the question of if you have the diagram that you can share and maybe run the audience through it at a top level so that they can understand what it's all about. So how scalable is it? How small, how big? What are the requirements? How do you go about determining the feasibility of a project in a given location?
Right. So the process is based on pyrolysis, but it's not the traditional pyrolysis that most people know. It has some, as I said, technological innovations to it. And it's actually quite sophisticated because the process is a continuous one. It's not batch-based. And in terms of scale, so when you have a thermal process like this pyrolysis-based process, so there's this balance point between the chemistry and the physics and where the energy conversion is most efficient at. And we've learned that that happens at a scale of between 2 to 3 metric tons per hour. And it depends on the input material. So our single module handles between 2 to 3 tons per hour, but the system is scalable. So you can place several modules next to each other or on top of each other if you have larger scales. The system is designed to work 24/7. We calculate everything by 8,000 working hours per year. And I know that the difference in scales when you talk to Israeli audience and US audiences is quite apparent. In Israel, the big scale of Israel is the tiny scale in the US. But actually, if you're thinking about the waste management market, then it actually makes more sense to treat the waste as close to the source as possible. And then actually having these 3 tons per hour modules makes more sense because their footprint is minimal and you can place them at the immediate outskirts of cities or industrial zones or even university campuses. And if they generate this waste, even 1 ton per hour scale of waste, then it makes more sense to treat it as close to the source as possible in the most energetic, efficient process there is. And then you save a lot of money and resources and pollution for that transportation of waste from the collecting stations to the landfill and so on. So this is the basic model, and the system is scalable, but we actually prefer we find that the smaller scales provide a more holistic solution.
Great, interesting. Thank you very much. So we have a question from Martin, who has asked, and this is actually a very interesting question: does the feedstock, the plastic coming in, the composition of the plastic coming in, determine the hydrogen that comes out, or how does that work? What kind of feedstocks can come in, first of all? And then secondly, like he mentioned, like he asked, how does that determine what your hydrogen output is?
Great. So yeah, the input material can be very diverse. It can be the municipal solid waste or different kinds of plastics or organic waste. It really varies. But if you're looking at plastics as input, as we all know, plastic ranges can come in different types. And there is this notorious PVC that nobody likes the chloride components thereof. And also a lot of time in the plastic industry, they add materials in terms of weight, like color or other components. So the identity of the plastic coming in is crucial to determine either the identity of the output energy and how efficient the process will be. So yes, it's crucial for us to know the composition of the input material, and we can handle all types of plastics. It might, if you're talking PVC or the not so comfortable types of plastics, then you would need some adjustments to the scrubber, so you won't have any emissions coming out of it. But yeah, the plastic definitely, the input definitely determines the output.
Right, and I think
I'll provide, perhaps as you requested, a sketch or a very general description of the system, so the technical audience can get more sense of what we're dealing with.
Okay, that'd be great. And any presentations we'll actually be putting up on the website, so people will be able to see them. So I think we have another minute and a half or so. So if I can ask you one last question, you opened your presentation, you were talking about net negative, net zero versus net zero. Is it possible to achieve net negative with the solution that Co-Energy offers?
When you're converting organic waste to biochar, you achieve net negative because the biochar itself captures carbon. In other forms of energy conversions, such as plastic to electricity or municipal solid waste to energy, then the process is net zero, but you don't get to net negative because you don't have that capturing material to produce the offset. So we're big believers in utilizing organic waste to create net negative. Organic waste is not only the bananas and vegetables that we eat, it's also wood chips and sludge, and as I said, feedstock manure. There's a whole world of organic waste that we can use to create net negative.
Okay, so it really is a project-by-project basis, core modular technology, but the outputs are going to be determined by obviously the inputs. Well, Thank you very much, Aviv. We are right on time.